right, as I said earlier, good morning and good evening, depending on where you're joining us. My name is Carrie Browder, and I am the city's project director at the Ocean Conservancy. I want to thank you all who attended last evening's webinar on the Plastics Policy Playbook and policies for your city, and all of you tonight to join us. I'll leave the formal introduction to my esteemed colleague, Doug Kress, who will be introducing Dr. Chelsea Rochman. Take it away, Doug.
Thank you so much, Carrie. Good morning, good afternoon, and good evening, and welcome to Science-Based Solutions to Macro and Microplastic in Municipal Waterways, a webinar produced by Ocean Conservancy and its urban ocean partners, Global Resilient Cities Network, and the Circular Initiative. My name, as Carrie said, is Doug Kress, and I'm the Vice President Conservation for Ocean Conservancy. I'm pleased to welcome you to a presentation on some of the emerging threats posed by plastics to humans and environmental health, and some of the science-based solutions cities are adopting in response to that threat. Nearly 70% of the world's population is projected to live in urban areas by 2050, and these population centers are critical in the fight to keep plastics out of our oceans. As it is, 11 million metric tons of plastic debris enters the ocean each year, and the threats to biodiversity and ocean health are considerable. City leaders are already tackling issues that impact the ocean, like water quality and waste management and others, recognizing that it's essential that we build stronger and more resilient and more sustainable communities in the face of climate change and other imminent threats. That is why Ocean Conservancy and its partners launched the Urban Ocean Initiative more than a year ago, creating a platform for city governments, community leaders, scientists, academics, and the private sector to come together and connect with one another to develop and share and scale solutions to the ocean plastics crisis while progressing the broader urban development initiatives as well. I oversee the Trash-Free Cities program at Ocean Conservancy, and it's an honor this morning, to be able to introduce one of my colleagues to lead this webinar discussion. Dr. Chelsea Rochman is an assistant professor in ecology and evolutionary biology at the University of Toronto and a science advisor to Ocean Conservancy. And she's researched the sources, the sinks, and the ecological implications of plastic debris in marine and freshwater habitats for more than a decade. Dr. Rochman holds degrees from the University of California, San Diego, the University of California, Davis, and San Diego State University. While a graduate student, she was a member of the first scientific expedition to investigate the Great Pacific Garbage Patch. She is considered among the world's leading experts on marine and freshwater plastic debris, and she currently runs a research program that investigates the environmental impact of microplastics and microfibers. Dr. Rochman has published dozens of scientific papers in respected journals, and is the lead author on an article that will be published in Science next month that estimates the considerable effort that will be required by all of us in the future in order to reduce emissions. With that, it's my pleasure now to introduce Dr. Chelsea Rochman.
Thank you, Doug, and good morning or good evening to everyone. I'll share my screen in just a minute, but before I do, I just wanted to make a note that if you have questions that come up during the presentation, please feel free to type them into the question and answer section in the webinar panel, and we will make sure to answer them at the end. I'm going to go ahead and share my presentation, and we will begin. Doug, can you see my screen? Okay, great. Well, thank you everybody for being here tonight or this morning. And I want to thank you, especially for those of you that are leading in cities around the world. I want to thank you for your leadership, especially on this important issue. So many different commitments have been made in order to make a difference on waste and plastic pollution, and we're really thrilled to see that effort. So tonight I'm going to tell you all the story of how plastic pollution became a scientific discipline, how we became to understand it in the environment, and I'll share a little bit of my own story as well in this field. So before we dive kind of into the past on plastic pollution, I wanted to reflect a bit on where we are today. Every day there's so many different news stories on plastic in the media. And so these are just a couple different examples that I found last week in the news. You see lots of news recently about COVID-19 and the increase in waste as a result. and also a paper that came out recently in Science that talked about the doubling or almost tripling of the amount of litter that's entering our oceans. And over the last 5 decades, the evidence about plastic pollution in our environment has been building, with a slow start followed by a really busy decade. So I'm going to highlight one thing from each decade that I think were fundamental in helping initiate this field and really the understanding and awareness around this issue. So believe it or not, it was 50 years ago when Ed Carpenter, who is now an emeritus professor at San Francisco State University, reported small pieces of plastic in the middle of the Atlantic Ocean in the journal Science. He also reported contamination in fish. This was an important finding, and it was 50 years ago, but it didn't exactly spark the beginning of a field. It took quite a while before it really started to gain attention. So I'm going to fast forward a decade to the 1980s. Here, the Sea Education Association started monitoring plastic in the oceans. Their business was taking undergrads out to sea and teaching them about our oceans. They began to notice plastic in their plankton trawls time and time again, and they began what has become the first long-term data set on plastic pollution, which has been incredibly foundational to this field. Then came the famous Captain Charles Moore, who you may have heard of because he discovered the Great Pacific Garbage Patch in the 1990s. This was described as a giant floating accumulation of debris that was twice the size of Texas. Although we know there's no huge island of plastic floating around in the ocean, we do know that there is a soup of dispersed plastic bits, but it's this story that really initiated the world to react. So I'm going to come back to the garbage patch in just a minute. Before I want to mention who I think is really the godfather of the scientific field of plastic pollution, and that's Dr. Richard Thompson. And he coined the term microplastics, which we will talk about later tonight when we think about different mitigation strategies for plastics that we can do. He saw and quantified these small bits of plastic for decades and sparked really what has become almost a divide in the field of those who study the small stuff and those who study the big stuff. So if you just take a look in the scientific literature, you can see that decade by decade, the evidence has been building to show that this is an issue worthy of scientific investigation, but also worthy, as we can see, of policy action. So let's come back to that Great Pacific Garbage Patch. This really captured the world's imagination. It may not have captured yours in 2006 when this article came out, but it certainly captured mine, and it's why I'm sitting here today talking to you about this issue. This article, written by Ken Weiss in the Los Angeles Times, won a Pulitzer Prize, and it brought marine plastic pollution into the public eye for many. After seeing this article, I became convinced that I would get my graduate degree studying plastic pollution, and I decided how I wanted to study how plastic affected wildlife so that I can increase our understanding and inform policy. And since this time, we've learned that it's not just about plastic floating in the middle of the Pacific Ocean. Plastic actually accumulates in all of those circular gyres or ocean currents in the middle of the ocean. And it includes the really big pieces like bottles and bags, but it also includes a lot of fishing gear. What I focus most of my time on is microplastic. The majority of the little pieces of plastic floating around in the middle of the ocean are less than 5 millimeters in size, and they've either broken down from big pieces of products or they entered as small, like microbeads in your face wash. But as we sit here today from cities around the world, I want to remind you that it's not just about the ocean. Today we know that plastic is contaminating our rivers, and it's also contaminating our terrestrial environments. And part of that is because plastic, the majority of it, enters the ocean from land and from the places in which we live. So I want to just spend a minute showing you, I guess, the reach that plastic pollution has had in order to be able to really show how it's become such an important part of the physical environment in ecosystems around the world. But then I want to talk about some of the sources and focus on solutions. So because there is global contamination, it means there's also widespread exposure in wildlife. Within the scientific literature, you'll find reports of hundreds of species interacting with both the big plastic and the small plastic. And for microplastics specifically, we know that more than 220 species have been reported to ingest it. And this includes at every level of the food chain. And that includes the food chain that we extract resources from. So this includes seafood, but it also includes the water that we extract from our freshwater sources. So microplastic has come to contaminate the wildlife that we love, but also the resources that we extract from our oceans and Great Lakes. So let's bring it back to why we're here tonight. Cities. Although plastic finds its way into some of the world's most remote locations, as I showed earlier, much of the contamination comes from where we live. And because most people live in cities and more people are starting to live in cities as our population grows, cities are a fantastic place to work on plastic pollution mitigation. And to inform mitigation, a lot of work has been done to look at the sources or the pathways of plastic into the ocean. And this includes from the cities in which we live. The sources are diverse. They include single-use plastic items, cigarette butts, textiles, so little bits of our clothing, tires, fishing debris, construction debris, and among many others. How this plastic enters the environment is also really diverse. And a really well-described pathway is mismanaged waste. We hear an awful lot about the mismanaged waste that comes from land into our oceans. Doug mentioned that 11 million metric tons of plastic flows into the ocean each year. That comes from a paper that was published just a couple weeks ago, and so I need to update my slide. But this number, 8 million metric tons, came from a paper in 2015, and I use it because it really mobilized the world to act. But the mismanagement of waste is not the only way that plastic gets into our oceans. So I want to talk about some of the other ways that plastic, whether it's mismanaged or from other pathways, enters our oceans from rivers and from our watersheds. And the reason I like to show this slide is because even if you're sitting in a city that's way upstream of an ocean, and it's hard to envision, the beach or the ocean because it's so far away, we're all connected. So even here, me sitting in the city of Toronto, close to the Great Lakes, eventually through the St. Lawrence River flows into the Atlantic Ocean. So as I said, there's many ways beyond mismanaged waste that plastic gets into the environment. So here I want to share some results from some work that I recently did looking at pathways for how microplastics enter the aquatic environment. The sources of microplastics are very diverse, and it includes atmospheric deposition via global dust cycles. But I'm going to talk about some other pathways that are a little bit more relevant to mitigation. And these include agricultural runoff, wastewater effluent, which you'll see as WWTP in many of these slides, and stormwater runoff. If you look across the scientific literature, there's been a lot of papers focusing on wastewater treatment plants as a pathway for microplastics to reach the environment. There are many fewer studies focusing on agricultural runoff, industrial runoff, and stormwater, but these are important pathways. And so I want to show you some results from a study to show that this is true and that these are good things to focus on for mitigation, particularly in cities. Now, I'm not going to focus on industrial plastic, but this would include runoff from the loss of pellets and scraps from plastic industry. We see this here in Toronto, but again, it's not the focus of the study I want to share with you tonight. So for a project that I did a few years ago that we're still working on writing up the results, so this is all unpublished data, but I'd be very happy to share it with you after this webinar. I was really interested in understanding the ways that microplastics reached aquatic ecosystems, but particularly from cities. So for this study, I collaborated with stakeholders in 4 different regions across North America. This included Sacramento Bay Delta in California. It included Mississippi River in the St. Louis area in Missouri, Lake Ontario in the Greater Toronto Area in Canada, and Chesapeake Bay near Washington, D.C., where I believe Doug and Carrie are visiting you from tonight. In each region, I sampled from 3 locations for agricultural runoff, stormwater runoff, and wastewater treatment plant effluent. I also sampled downstream of these pathways to compare what I was seeing in the environment to some of these different sources. So I'm just going to walk you through some of the results. So we sampled bulk water, so we're just taking a bucket and sampling water from the environment. And this was from downstream of these pathways. So on the left, you can see the amount of anthropogenic microparticles, which includes microplastic, in each water body downstream of the pathways. And on the right, you can see the concentrations in agricultural runoff, stormwater, and wastewater treatment plant effluent. The first thing I want you to notice is that there are more particles in the pathways than downstream. This is no surprise because they dilute when they end up in that water body like Lake Ontario or Chesapeake Bay. But the other thing to notice, which I think is more important, is that across the regions, the most important pathway or the largest source varies from region to region. This stresses how important local monitoring is. So when you're trying to figure out what to focus on in your city to reduce or prioritize the prevention of microplastics, local monitoring is really important to inform your prioritization. We also wanted to see whether the pathways varied. So this graph is confusing and I'm going to walk you through it and tell you exactly what it means. So what you're looking at are plots that treats each type of sample. So each dot on each plot is a sample, and it treats it as a community of microplastics. And the different shapes of microplastics in a sample, so the fibers, the rubber-like particles, the fragments, those are what make up the community. The dots or samples that are closer together mean they're more similar to each other. Here, the water body samples, so downstream, are green. The stormwater is red, the agricultural runoff is black, and the wastewater treatment plant is blue. The large graph on the left is across all regions, and the separation between those pathways shows you that there are differences between pathways. The ones on the right is from each different pathway. And so you can see here that except for Chesapeake Bay, there are differences in all of the different pathways. So this means if I'm out monitoring, there might be a unique signature that I might see in the ocean or in the nearby lake that suggests a certain pathway or source. So what are those? Here you're looking at the different morphologies or the different types of plastic shapes that we see across each region in the different types of pathways. All I want you to notice here is this dark red color that tends to be in stormwater in every region. Those are black rubbery particles. We believe those are related to tire dust. And the high amounts of microfibers in wastewater treatment plants, which are related to washing our clothing in washing machines, little bits of fibers coming off, going out into the wastewater treatment plant and ending up in the environment. Now this trend is very similar to what we saw in the San Francisco Bay, where we saw microplastics in both wastewater and stormwater, but that more than half of the particles in wastewater were fibers and half of the particles in stormwater were tire dust. And here you can see that stormwater is 300 times greater of a pathway than the wastewater load to the bay. So if I were somebody who was a leader in San Francisco, California, I would focus on stormwater in terms of mitigation strategies. So overall, within these studies, I just want to point out that there are many different pathways bringing microplastics into the aquatic environment. I only talked about stormwater, agricultural runoff, and wastewater treatment plant effluent. I could have talked about industrial effluent. I could have talked about atmospheric deposition. So there's other places that you can focus. The major pathways in our study varied by location. There was no pattern that was consistent, which means that local monitoring to inform local solutions is really critical. Different pathways have different microplastic signatures, and I think these can be used to determine which pathways may be important drivers of contamination in our system. So if I'm sampling sediment in my local lake, and it has rubber particles in it, I might think stormwater is an important source. So combined, this data is really important to inform mitigation strategies. So let's talk about those. The first thing I want to mention is that when it comes to how we prevent or clean up plastic pollution, there is no silver bullet solution. We need diverse strategies that work in parallel at the same time, and different strategies will be more appropriate in different locations based on your main sources, but also maybe based on cultural differences or socioeconomic status. And so I tend to think of these different options sort of falling into different bins or categories, and they're plastic waste reduction. So I'm not going to talk very much about bans on plastic items in this talk, because that's maybe not so, it can be specific to cities. And if you see that as a common item, you could think about something like that. It could also be increasing waste management. I'll talk about some of those options. And it may also be the cleanup of plastic pollution, which I'll also talk about some of those options. So all three of these there are different strategies within each. I think Carrie has either sent you or will send you a one-pager with some ideas of how to mitigate plastic pollution, and specifically mostly microplastic in your city. And these are different examples of either cleanup strategies or different waste management solutions. And I want to focus on a few of these and how they may be relevant to the study I just showed you in North America. So in the San Francisco Bay, as well as here in Toronto, stormwater is a major source of microplastic into our environment. So in our city, we might want to consider rain gardens or bioretention cells. Rain gardens you sometimes see on the side of the road, and as the water comes down the road, it goes into the storm drain. What a rain garden does is it filters the particles through the sediments and the soils in the garden, and then it sends the water out into the bay. So in this case, we have samples that are going into the drain and samples that are going out of the drain. And you can see that going into the drain is always much bigger than coming out. So we captured 90% of the microplastics in stormwater by using rain gardens or bioretention cells. They're also great to capture pesticides and other types of organic contaminant. In the Chesapeake Bay, as well as Lake Ontario, wastewater treatment plant was also a major source. We had lots of microfibers in our sample. And so in our cities, we might consider, this is a mistake, this is supposed to say washing machine filters, but we might consider putting filters on washing machines to trap the microfibers before they go to the wastewater treatment plant. So here is some data with the number of microfibers after washing a load of laundry with no filter. And here is the number of fibers per liter after washing laundry with filters. Again, we see about a 90% reduction of microplastics with a filter on a washing machine. Now, although this is not about microplastics, I have a real affinity for these types of solutions. I think they're adorable. They're great to attract the attention and raise awareness in your city, but they also capture litter before it gets out into the environment. So large plastic debris can also be captured in rivers or in waterways. So these are examples from the Chesapeake Bay, which I did talk about in the study, but we didn't quantify the big stuff. And then these are examples from Toronto. So we have a trash wheel and sea bins. These are also on the one pager that we'll send around. But of course, these aren't the only solutions. Other types of solutions you might consider, maybe trying to really build a circular economy within your municipality. Maybe you live right on an ocean with a big fishing community and you want to incentivize the return of fishing gear. Maybe you're trying to increase your cleanup with maybe on the ground more coastal cleanup, or reducing single-use plastics. Say during cleanups, you see that straws are the most common thing that you see on the beach. Maybe you think about something like a reduction in straws, the Skip the Straw campaign. So as I said, there's many different solutions, and as we choose what we work on, we also need to have many different people come to the table. So we need stakeholders that are working across the aisle, as well as people from government, industry, and scientists, and even the public working together to inform the best management, to harmonize the products we procure or use with the most sustainable end-of-life solutions, and to put policies in place to facilitate and lay the foundation for success. So I really do believe that success stories and on-the-ground work will happen in cities. And I think cities have a real opportunity to lead. And although with plastics, we need to think globally and even collaborate globally, a lot of our actions will likely be very local. So I think a type of cities initiative, as you're all working on, is really important because, as I said, waste really is managed locally. And I think if we work together, we can empower cities to take leaderships on the issues that prevent measurable emissions of plastic waste. So if I were running a city, I would aim towards 100% waste collection and capture. I would try to send less to landfill and more to recycling and compost. I might try to have waste harmonization with cities around my municipality so we can all recycle the same things, they go to the same markets, so it's clear for the public to increase their waste literacy and understand the issue. And I might also formalize cleanup, maybe with trash wheels or sea bins or with coastal cleanups with the public. And I also think we can work together with nearby cities or even cities far away that have similar issues to share success stories and lessons learned. Because overall, we all have the same shared goal, which is to reduce the amount of plastic going into the ocean. And so going forward, so this is my last slide, but I want to say that going forward, I'd be more than happy to offer myself, any researchers in my lab as someone you can look to for any advice or any questions you may have. And of course, for the remainder of our time in this webinar, I'd be very happy to answer any questions. Thank you.
Thank you very much, Dr. Rochman. We appreciate you taking the time. It was a fascinating session. We have one question in the text box, and we have a few that were submitted early. First question is, can you please comment on the impact of bioplastics?
Of bioplastics?
Yes.
Yeah. So I can't really speak to the impacts of bioplastic from how many resources they use when we make them or what they emit during making them. But what I can say is that it's really important that we do build a more circular economy, meaning that we start to value the plastics that we make and we're able to reuse them or truly recycle them. And right now, the markets for recycling a lot of these bioplastics maybe don't exist. Or when they say they're biodegradable, they really mean in an industrial compost facility. So if we're going to build bioplastics as part of the solution, we have to make sure that they fit and they're harmonized within the waste management systems that we have locally. A good example of this is that here in the city of Toronto, we see a lot of restaurants switching to the PLA or the compostable, it says BPI compostable certified on it plastic. And they do this because it looks like they're doing something better. But the reality is we don't have an industrial composter. So that material goes in my landfill. Whereas if the restaurant purchased a recyclable, say PET or polypropylene container, it actually would have been more sustainable, even though to the eye, the public might not have seen that. So it's really important that if we use bio-based plastics, that we use them in a way where we're not greenwashing, if we want to use that term, or where at least we're really being sustainable.
Thank you, I appreciate that. Next question is it very expensive to monitor the waterways to identify the most common local source of microplastics? And is it something that would work as part of a citizen scientist program?
That's a fantastic question, for which I have several answers. So let me make sure that I capture both of those. So Carrie, if I only answer half, let me know. Yeah. So the first part I think was, is it expensive? It depends, and I don't think it has to be. So when you sample plastic pollution, the smaller the plastic you look for, the more difficult it is to be able to quantify and characterize without fancy equipment. But if you're simply just trying to understand the sources and you're really trying to understand how much you have, I think you can sample the bigger stuff. And often if you have bigger plastics, you are likely to have smaller plastics. So if you're aiming for plastics that are 0.5 millimeter in size and greater, it's not as expensive. And actually we have training protocols for how you sample it, how you quantify and characterize it, and also how you kind of characterize it by morphology to help to understand the sources. For the citizen science piece, this is where now this is possible, right? So when you're looking for larger pieces, you can 100% have a campaign that increases awareness and collects data at the same time. You just have to be thoughtful about where you sample. So if you're really trying to understand the sources, choose sites that are downstream of some of these different pathways so that you can measure the differences in concentration around those places. So I think it's absolutely possible to do it in a cost-efficient way and to do it with the public. You just always, with any monitoring strategy, make sure your design of your monitoring strategy meets your objective. I think I answered both questions.
The second one was as part of a citizen scientist program. So
I was going to say, Chelsea, the questions are fascinating. I'm watching them coming through on several screens here. You clearly have inspired or engaged an audience, so well done.
Well, I'm glad I talked fast then, because we have lots of time.
Well, there's a lot of pros to that, so that gives us time to answer these questions. The next one we would like to ask you is if you have this type of data that's shareable for the Pacific, including China and Japan, more specifically the quantity of plastic waste.
Like within that region, is there data within that region?
That's how I understand the question.
Yeah, so I mean, I personally don't, but there's a lot of actually really good studies that have come out of China and Japan. We've been working on the ground with Vietnam to try to work to understand sources and build monitoring strategies with them. But please feel free to reach out. I can share with you the literature that I know, or at least connect with scientists on the ground in these different places. The plastic community is really growing and it's really international, and we tend to know each other. So I'd be more than happy to make connections.
Thank you. Maybe we can include some of that in our follow-up email next week.
Mm-hmm.
Next question is regarding washing machine filters. And are they attached to machines automatically, or do you have to request it?
Yeah. So the current ones that exist tend to be aftermarket filters. So that means you buy them from a second party, third party, and you install them. So the way that it tends to work is you're putting them on the outside of your machine. I personally, while I think filters on washing machines, it's a good solution right now to have to purchase them and buy them. But what I hope that our data shows, so we did just a study in the lab to show you the data that I did. Right now, we're working with a nonprofit called Georgian Bay Forever, where we have, in a small municipality in Ontario, we have 100 volunteers that put washing machines on their home. That's 10% of the city. We see a 10% decrease at the wastewater treatment plant in microfibers. It works. We're hoping that kind of data can fuel legislation that suggests that washing machines should be made with filters in them. And the way to think about that is your lint trap on your dryer. It would simply be a lint trap on your washing machine. I have heard rumor that washing machines in Asia and Australia have them already, but we don't in North America, and I don't think they do in Europe either.
Thank you. Do bioplastics contribute to microplastic problems in the ocean, or do they break down differently so they have different impacts?
So they should break down the same. So it depends, right? The bioplastics that are most commonly on the market right now, the PLA, has a very similar chemical structure to many of the plastics that we use, the PET, the water bottles. And so it breaks down the same. We see it in the environment as microplastic. Whether it interacts with organisms differently, I don't know. But in terms of a physical effect, it should be the same. It's the chemical effect that I'm not sure of.
Thank you. And then we had another question. Who do you think are the major industry players in this field? If someone wanted to get a job working on the plastics problem, where would you recommend they look?
Well, it depends on, I guess, there are so many different ways to work on and tackle this problem right now. I think that question was industry, right? Who are the major players in industry? So, you know, I think both Carrie and Doug can attest to this too. We've seen over the last decade, more and more companies kind of come on board with wanting to make commitments, wanting to do something. There are groups that bring these industries together. So there's the Ellen MacArthur Foundation that's bringing together a group working on circular economy. There's the Global Alliance Against Plastic Waste. These would be great organizations to reach out to see if there are positions to work in sustainability within those industry. But also there's probably great government positions to work within a municipality, to work with the industry, to get mitigation on the ground, work together. And you know, I often don't see in these types of meetings waste management people at the table. More and more I do. I know they're interested, but they seem to have their own meetings about it. So that's another great position to go in. Then there's science, and there's NGO. So many options. It just depends on what you want to do.
There's one thing you should just include to this, and I don't think enough consumers or just the average person in the street understands their power as a consumer and their ability to demand change. You're talking about trying to bring on systemic change from not quite the top down, but certainly from within the industry, hoping for some goodwill. Quite often the ability to make a difference with what you pay and how you influence the producer is itself estimable. And so if you're wanting a washing machine with a filter on it, if you're asking the corporations to produce that, it's going to happen sooner than later. That's why we have seatbelts on cars and everything else. There's change comes from those who have the buying power.
Thank you, Doug. And that's a perfect segue into a question I see in the chat. I just want to remind people to please put their questions in the Q&A so we can track them. But how would you recommend to involve government in the fight to reduce plastic waste? And do you know of any laws, either locally or globally, that you would look to?
Oh man, yeah. So, I mean, I personally think government should be very involved in the fight against plastic waste. I think personally that it should start, so I could start at the local level or I could start at international. I'll start at international because it lays the foundation. There are people within the United Nations, there's an ad hoc working group trying to decide whether we need an international agreement for plastic pollution. I don't think it's a bad idea. If I were to build one, I would build one that looks like the Paris Agreement for climate change. The reason being that I think if we have reduction targets, people can then mitigate in the ways they want to mitigate that make sense for them. And so that's where I think that builds a foundation and the building blocks to do that. But then I would say from there, you want to have governments working at the federal level, at the provincial, some places state level, and then city level together to produce different laws. And we see kind of a scattering of different things. So here in Canada, at the international level, at the federal level, they're talking about different bans on certain types of single-use plastic products. The ones that aren't easily recyclable, they're talking about getting rid of. That should happen by 2021. They're also thinking about standards for recycling. So saying that 20%, for example, of new products should come from recycled material to incentivize or to, I guess, force more recycling and plastic made from less virgin material. But at a city level, that's where you can use stormwater bylaws, and in order to put rain gardens on storm drains, you could use cleanup strategy funding that you use to clean or green your areas. And then, of course, you can also have some say on product usage. So I'll admit I'm a fan of government, whether it's good or bad, but I think there's a lot of room for government to come in and not force, but support to make a lot of what we're trying to do feasible.
And I'd also just like to make a plug for the Plastics Policy Playbook, which we discussed last night, and that will also be shared at the end of this. There should be some useful information in that as well. Next, of course, a compliment, great presentation. What is your view on using remote sensing technologies to track/monitor macroplastics in municipal waterways? Many Asian cities are experimenting with innovative technologies using machine learning algorithms to identify river plastic in real time with varying levels of accuracy.
I think it's great. So it would be much more easier, right? If we can go the remote sensing route, we can really understand where are the hot spots. If we can use machine learning to think about what those products are, if the machine is if the algorithm is trained to know, hey, that's a bottle, that's a bag, we can think about different mitigation strategies we can do. I would also, this isn't necessarily remote sensing, but because it's difficult for microplastics, but we've been trying to create algorithms working with others for microplastics. So somebody asked the question about citizen science or community science, and we're trying to make it so that if they sample, they can feed it, they take pictures and feed it into an algorithm that tells you, you know, fiber, foam, fragment, whatever it is. So I think remote sensing, machine learning, all of it, there's a ton of room for it. Right now, and this isn't for macroplastic, but this takes time too, it can take up to 20 hours to do one sample of microplastic if you're trying to go really small. And so doing this in a more remote way would really make things more efficient.
Thank you. We have two questions that are semi-similar, so sort of lump them together. Are you aware of any microplastic effect on the agricultural sector, and how could we reduce plastic in agricultural water?
Yeah, so I'm not aware of any effect in terms of microplastic harming the agricultural sector. But I will say that microplastics are in soils, and that is because, well, one reason is because when we use wastewater treatment plant sludge as a fertilizer, which there's lots of reasons to do that, but one byproduct is microplastic in the soil. So we do know that it is there. There are people who are trying to understand what that means for your microbial community in the soil and maybe for your crops, but at the moment there's not an evidence of a devastating effect to agriculture. But there is plasticulture that is used in agriculture. So there's mulch is often made of plastic. Sometimes there's slow release pesticide that has a plastic polymer around it. And so this is why in Sacramento, for example, agricultural runoff seem to be a big source of microplastic into that region. So I think we can think about sustainable agricultural practices that use less, maybe either use less plastic or use more durable plastic, or we have some sort of vegetation on the side of the road that filters the runoff before it enters the environment.
Thank you. Could you refer to any sources that study the effects, the health impacts on humans of microplastics?
Humans. Yeah, so that is a new field. I would say that over the last 5 years, people have really worked hard to understand human exposure. So understanding how much microplastic is in our drinking water, to think about how much we're exposed to, understanding what's in our seafood, how much is in the dust, how are we exposed. We've gotten to the point where we say, okay, we know we're exposed. There was a recent study from a guy who dosed himself with plastic just by wearing fleece more often and drinking out of water bottles that then measured microplastic in his stool. But the health effects are less understood. And there are some review papers. There's a scientist named Stephanie Wright, who's at the University College London, that has done some great work on showing what might happen and saying these are the hypotheses we should test. But I would say that it might be still really right now, governments are asking for it. So there is research being done, but it might be a couple more years at least until we know, even have an idea of kind of what it means for human health.
As a quick follow-up to that to you, Chelsea, when the Break Free from Plastic Pollution legislation was introduced earlier this year in the US Congress, a number of the speakers held up credit cards and said, you're ingesting essentially a credit card of plastic a week through microplastics. Is that a good example of the amount of plastic we're taking in?
It's actually not a terrible example. So when the WWF was coming up with that number, I chatted with them and saw what equation was going back there. And it's not crazy. It's just that the reality is a lot of that will be excreted. So the question is does it matter, right? And we're trying to understand whether or not it does. And it's not like you're eating a whole, I mean, it sounds gross, but it's little bits that you can't see.
It had the measured impact they wanted, I guarantee you, but still,
sure did.
As a quantity, that's just to get your head in that place. Thank you.
Yeah.
Personally, ingesting any plastic I would like to avoid, so that's why I appreciate that we're talking about this right now. Transitioning a little bit, Can technologies like plastic to fuel be a solution?
Technologies like what?
Plastic to fuel?
Oh, yeah. So there have been some engineering solutions. One is turning plastic into fuel. The other is turning plastic into plastic, but with chemical recycling. So, uh, for those that when you think about recycling, often when we talk about recycling, we're talking about mechanical, and it's literally just grinding it back down, melting it into the same type of plastic, and producing something out of it. When we turn it into fuel or do the chemical recycling, you're turning it back into its original building blocks. You have more flexibility to use it for other things. So I don't know as much about either of these because they haven't been scaled up, but I can say that they don't sound like bad ideas, particularly where you have plastics where mechanical recycling is tricky because it's a low value plastic like a film or something that just can't be mechanically recycled. But I don't claim to be an expert on these things, so I would dig in yourself.
We'll have to look into that a bit more. I actually think I either read something or attended a seminar recently that said that they're still developing the science on plastic to fuel and what other emissions or other, what could be the outcomes of that. I'll see if I can track it down to include in our community of practice.
Yeah, that would be great. Everything I've seen is really small scale pilots of using it.
There are more questions if you have time.
Yeah.
Are there any plastic policies in your country, and are they followed by the industry and people? How do you make sure that these rules are followed?
Yeah, so the plastic policies that currently exist here in Canada, so there's ones that are coming down the pipeline, but the ones that currently exist, let's say in Ontario where I am, we have a bag tax. So when we go to the store, we pay for plastic bags, and we do see reduction in plastic bags and a lot of people bringing their own. With that, so here in Ontario, often I do see them actually charging. I know that up north in Iqaluit and Nunavut, oftentimes, even though they have the bag tax, sometimes they don't actually get charged. So I guess there's always that like checks and balances with regulations. Another rule or law that we have here in Ontario is extended producer responsibility. Our waste management is 50% of it is paid for by the plastic industry, and 50% of it is paid for by the cities, and that works. And there's talk of that changing to 100% paid for by the industry, and that does happen in British Columbia. So I think here I would say that most of the laws that are here are followed, and there's a lot of laws that are coming down the pipeline. But this is why I think it's so important that we need the multi-stakeholder collaboration so that everyone is sort of on board as we bring on these new policies, and we're all working together and choosing things that work right across the public, the industry, the government, etc.
Follow-up question, the 50% to potentially 100%, is that because of legislation?
Yeah, so when Canada introduced its international, or I keep saying that, its national plastic strategy about a year ago, that was one of the things on the list. And so Ontario will switch from 50 to 100.
Thank you. Do you know of any cities with deep ocean outfalls that have succeeded in reducing the amount of microplastic contaminants they are discharging from their treatment plants? It's always better to stop it from entering the wastewater system in the first place, but are there solutions already in place prior to discharge?
Prior to discharge or within the plant?
Within the plant, before it discharges.
Yeah, so we, when we were in San Francisco doing some sampling of wastewater treatment plants, we looked at across 8 different plants, and some had secondary. So there's the primary treatment, secondary, and tertiary. We sampled plants that had both secondary and tertiary treatment. Secondary means it just goes into the vat and the big stuff settles, and that's and then it goes through the microbial degradation or the microbial process, and then that's that. With the tertiary, it often either goes through a sand filter or something else. We did see a significantly less microplastic in the plants that had tertiary treatment. So I think advanced treatment does help. in California, in some places, Southern California, wastewater is turned into drinking water. Through that process, it will also remove microplastic because it's even more finer filtered. So yes, there are some things that can happen at the plant. I agree with this person that upstream is also to do them both at the same time. But yes, wastewater treatment plant is an important step.
Thank you. And then will stormwater gardens lead to soil pollution?
To what pollution?
Soil pollution.
Yeah, that's a good question. So when you have bioretention cells or rain gardens, or sometimes people just have permeable pavements, they do have to be changed. So that garden is sort of taking one for the team. It needs to be removed. It will hit saturation and it will have to be removed and stored as like a, I don't know about hazardous waste, for example, but it goes somewhere else and is removed from the environment and the soil is changed. So it's confined, it doesn't mix with the other part of the ecosystem. So yes, it will hit saturation and that soil is certainly being contaminated, but it is the mitigation strategy and it is contained to that.
Thank you. And then can you share any technologies to identify microplastics in water, and how can cities approach the technology? I know we have the one pager that we'll be sharing through the community of practice, but I don't know if there's any you'd like to mention here.
Yeah, so I mean, I think if you're interested in creating a monitoring strategy and you want to sample, there's a couple different ways to do it. One is you're just taking a water sample. So you're taking 10 liters from the environment and bringing it back into the lab. Another is you drag a surface net around or you take a sediment sample. Once you're in the lab, the technology that is there, often we use metal sieves just to size fraction the sample, and often, you know, we might go down to 100 micron. You don't need to go smaller than that, I don't think, for the purpose. And like I said, you could go to 500 micron. Microscopes are used to be able to look at the particles and quantify them and characterize them. If you go the next step of confirming the plastic type, which is useful to know that it's microplastic, that's often Fourier transform infrared spectroscopy, so FTIR, or Raman spectroscopy, or GCMS. So that's where the technology starts to get expensive. But I would be more than happy to share like detailed protocols, images of what some of these nets and sieves and these things look like. And definitely, I mean, yes, it's an added expense, but it doesn't have to be as technologically challenging if you just focus on the bigger pieces.
Thank you. I think we have one more. I wonder if modern pipe materials like PVC and PE are contributing to the problem. They are resilient materials in terms of seismic risk, but could also contribute to the contaminant plastic load. Do you have any opinions on this?
Polyethylene and PVC, was that what it was?
Yes.
So yeah, I would say that in the environment, the most common plastic types that we see are polyethylene, so that PE, polypropylene, and actually polyester, so microfibers from clothing, PET, but not necessarily from the bottles, from the textiles. We do see PVC in the environment, but believe it or not, we don't see it as often as we see these other types. And I think it's because it seems to be that the proportions of what we see sort of matches the proportion of how much is produced and consumed on the markets. So the question in terms of polyethylene, yeah, we see that very commonly. Polyethylene, PVC is out there, but we don't see it as often.
Well, thank you, Dr. Rochman. We really appreciate you taking the time. I know that there has been a lot of interest in this topic. I also want to thank you, Doug, as well for the introduction this evening, and our partners, GRCN and TCI, the Circulate Initiative, for hosting this with us. As we mentioned at the beginning, we will be following up with more materials, the video recording, and answers to some of the questions we received before this through the community of practice next week. I believe a link was added in the chat for the community of practice. So please sign up, and we hope to have more opportunities to speak with Dr. Rochman and plenty of other specialists as this year continues. Thank you all again for attending tonight or this morning, wherever you might join us. And we hope to see you again soon.
Thank you very much. Thank you, Chelsea.
Bye, everyone.